If you're liking pursuit opens a new unexplored door. Tune in and soar with us, let's flow. Discover the unknown, see where.
All right, strap yourselves in, everyone, because today we are diving deep, deep into the world of material science.
Ooh, sounds exciting.
It is, trust me. And get this, researchers are using AI, artificial intelligence, to unlock some incredible new possibilities.
Okay, I'm all ears.
We're talking about a paper, it was published just last November in Nature.
Oh, wow. Nature. Impressive.
It's called, well, it's a bit of a mouthful. Scaling Deep Learning from Materials Discovery.
Catchy.
I know, right? But the findings are amazing.
So what kind of discoveries are we talking about?
Well, essentially, researchers used AI to find millions of potentially stable crystals that have never, ever been seen before.
Millions.
Millions. It's like discovering a whole new periodic table.
That's insane. Okay, so before we get ahead of ourselves, can you set the stage a bit?
Absolutely. You know how you're really passionate about clean energy, right? Well, just imagine trying to find brand new materials for like super efficient solar panels or next-gen batteries. That process traditionally has been incredibly slow and expensive, like searching for a needle in a haystack.
Yeah, I can see how that would be a problem.
Exactly. Before this research came out, we only knew of like 20,000 experimentally verified stable crystals, and maybe around 48,000 computationally predicted ones.
So not a whole lot.
No,
Okay.
especially when you consider all the possible combinations of elements that are out there.
That's a tiny fraction.
It really is. So how did this research change the game? Well, enter GNOME.
GNOME, what's that?
That's it stands for Graph Networks for Materials Exploration.
Okay, I'm intrigued.
So GNOME is a deep learning model, a type of AI specifically designed to explore materials.
Interesting.
And the researchers, they trained GNOME on the existing data of known stable crystals.
Okay, so they fed all this information into GNOME.
All kinds of information about their atomic structure and their energy levels, all that kind of stuff.
So they're basically teaching a computer to be a material scientist.
It's a good way to put it. Like, you know how AI is used to recognize patterns in language or images? It's the same idea here, but instead, GNOME is learning these fundamental principles that determine if a material is stable or not.
Okay, I see. So instead of spending years in a lab mixing and matching elements, this AI can analyze the data and be like, hey, this combination might actually work.
Exactly.
That's pretty incredible. So what happened when they let GNOME loose on the world of potential materials? What did it find?
Well, it didn't just find a few new materials. No.
Uh-oh. What's that tone?
GNOME predicted the stability of millions of potential crystals.
Whoa, wait, millions?
Millions. But of course, they had to make sure those predictions were accurate, right?
Yeah, how'd they do that?
They double-checked everything using something called density functional theory calculations.
Sounds complicated.
It is, very. And it's the gold standard for material simulations. So, you know, it's the real deal.
So what were the results?
Well, get this. GNOME found over 2.2 million structures that were stable
Compared to what we already knew.
compared to the existing databases.
Wow. Okay, so this isn't just about finding a few new materials. It's like rewriting the textbook on what's possible.
Exactly. To understand the impact, you have to think about something called the convex hull of materials.
Convex hull.
Yeah, it's like a map of all the best, the absolute best materials we know of,
Okay.
where every single point on that map represents a winning combination of elements, you know, a stable one.
I see.
What GNOME did was basically add hundreds of thousands of brand new points to this map.
It expanded it, like, exponentially.
Exactly, like going from this tiny little town map to this detailed atlas of the whole world.
That's a great analogy.
Thanks. So I know what you're thinking. Were there any discoveries that really blew the researchers away?
There had to be.
Oh, there were. GNOME was so good, especially at predicting materials with 5 or more elements. And those, by the way, are called quaternaries.
5 elements. That's a lot.
It is. It's like a chef trying to make a masterpiece with 5 completely random ingredients.
Yeah, most chefs would probably run for the hills.
Probably. But GNOME just aced it. It excelled. Makes you wonder what other secrets this AI can uncover.
Seriously, what else can it do?
Well, here's another mind-blowing thing. GNOME also predicted the stability of structures found using something called Ayres ab initio random structure searching. It's basically designed to randomly explore material space like a shot in the dark.
Randomly. And GNOME could still predict what it would find.
Yeah, It was consistently exceeding expectations, finding stable structures that even, like, the most advanced search methods missed.
So it's not just brute force calculation. It's like
Right.
GNOME has developed an intuition for material science, like it actually understands it.
Almost like a human expert, but, way faster.
That's amazing, but I have to ask, are these discoveries just theoretical, or can we actually make these materials in the real world?
That's what's so cool about this. 736 structures predicted by GNOME have already been created and verified in labs around the world.
Wow, so this isn't science fiction, it's happening now.
Exactly. And with so many new materials out there, where do we even begin? Well, I know you're interested in clean energy.
Always.
So let's start there. Imagine, what kind of impact could this research have on things like solar panels or batteries?
Oh, the implications are huge.
Right.
Remember those limitations we talked about earlier, like the slow process, the expense?
Yeah.
Well, imagine we could use these new materials to create solar panels that are twice as efficient,
Whoa.
or batteries that charge in minutes, not hours.
That's what I'm talking about. This is getting really exciting, but you know what? This is just the beginning of our deep dive.
There's more.
Oh, yeah. We still need to explore all the other implications of this research, what it means for the future of materials science. I have a feeling we're just scratching the surface here.
Well, don't leave me hanging. What else is there?
So we've been talking about GNOME's ability to discover all these new materials.
Oh, millions of them.
Millions. But this research also really makes you think about how we even, approach scientific discovery in the first place.
In a way, yeah. It's fascinating, right? GNOME isn't just like churning out new materials.
Right.
It's challenging all our assumptions about what's even like scientifically possible.
I see what you mean. For centuries, scientific progress has relied on human intuition.
Trial and error.
Yeah, exactly. We make guesses, we design experiments, we slowly piece together knowledge over time. But GNOME seems to be doing things so differently.
It really is. It's like GNOME is looking at materials from this completely new perspective.
A fresh perspective. I like that.
Yeah, making connections that we humans just wouldn't think of.
I mean, it's finding things that even, the most seasoned scientists would have missed.
Yeah, and it's doing it so fast. It really makes you question, the limits of human thinking.
You think we're just so used to seeing the world in a certain way that we're blind to, other possibilities?
It's totally possible. It's like that saying, you don't know what you don't know.
Exactly.
GNOME is showing us there's so much knowledge out there, we're just barely scratching the surface.
And that's what's so exciting about it.
For sure. Just imagine what we could accomplish if we combine the power of AI.
With, human creativity.
Exactly.
Oh, yeah.
It's a combo that could lead to breakthroughs in so many fields. I'm talking medicine, energy, you name it.
Okay, I'm all for pushing the boundaries of science.
Right.
But I also wonder, are there any, potential downsides to this kind of accelerated discovery? Is it like opening Pandora's box? Once you unleash this kind of power, can you even control it?
It's a great question, and honestly, it's something that all the researchers and policymakers are thinking about very seriously. It's powerful stuff.
Yeah.
We need to make sure that these discoveries are used for good and not for harm. That's why, responsible innovation is so crucial.
So, in the context of all this, in the context of material science, what does responsible innovation actually look like? We're talking about materials that could completely revolutionize industries.
Entire industries, yeah.
How do we ensure that those revolutions are, beneficial and not destructive?
That's the key. I think it starts with transparency. We need to be open, honest about the risks, the benefits of these new materials.
Be upfront about it.
Yeah. And we need to get everyone involved in the decision-making.
So it's not just, the scientists and engineers in a lab.
No way. Policymakers, industry leaders, even the public, everybody needs a voice to make sure these discoveries are used in a way that benefits everyone.
A collaborative effort.
Exactly. We also need to establish some ethical guidelines, regulations, to make sure everything's used safely and responsibly.
It's a big task.
Huge. But it's one that we have to tackle head on.
This deep dive has definitely given me a lot to think about.
Me too.
We've gone from the tiny world of atoms to the big world of what this means for society, for the future.
That's a lot to process.
The questions this research raises they're exciting, but they're also a little bit scary.
Well, that's how you know it's groundbreaking, right?
Yeah.
It forces us to confront the unknown, the what-ifs, the potential consequences.
I suppose so. But are you optimistic?
I am, actually. I think this research is a turning point for material science. And with the right planning, with foresight, we can harness its power to create a better future for everyone. A better future for all.
I like that. I like the sound of that. But speaking of the future, this research also makes me think about like how we make things. If we can predict, the properties of all these new materials, how is that going to change? Like manufacturing?
Manufacturing.
Yeah. Will we see a shift away from like mass production towards more customized, on-demand manufacturing?
Now that's interesting.
What if you could like go online, design a product with all these newly discovered materials and just 3D print it at home?
Whoa, that would be amazing.
No more one-size-fits-all products. You get exactly what you need, exactly what you want.
It would be like science fiction becoming reality.
Exactly. But a shift like that would, it would impact the entire economy. What would happen to all the manufacturing jobs? What about the environment? There are so many questions.
Absolutely. This is a call to action for everyone, researchers, policymakers, industry leaders, to really come together and figure out how to shape this future, how to use these materials to benefit humanity and the planet.
This deep dive has been incredible. We've talked about GNOME and how it could revolutionize everything from clean energy to manufacturing, but we've also touched upon some pretty big questions about the future of science, about ethics, about the very nature of discovery. This is an incredible time to be alive.
It really is. It's a future full of challenges, but also full of opportunities. The world of materials is about to get a whole lot more interesting.
Okay, so we've covered a lot of ground in this deep dive into AI and materials discovery.
It's been a wild ride.
It has. We've talked about how GNOME is uncovering millions of potentially stable crystals.
Which is insane.
Totally insane. And we've even touched on how this could impact clean energy, electronics, manufacturing, so many things.
And it feels like we're just scratching the surface.
Exactly. We're seeing a whole new world of possibilities opening up, and, well, we're just starting to explore it.
So where do we go from here?
That's the big question, right? Let's put on our futurist hats for a minute here.
Okay, I'm putting it on.
What are the long-term implications of all this? What are some of those big unanswered questions?
Well, I think one of the biggest questions is, if AI can predict the stability of millions of materials, what other secrets of the material world can it unlock?
That's a good question. Like, are there, hidden properties, phenomena we haven't even discovered yet? Maybe even like completely new laws of physics.
It's possible. Maybe AI can help us uncover those too.
AI revealing the secrets of the universe.
It's mind-blowing.
It is. It really is. But okay, let's think a little more practically here. How might all of this change how we design and engineer new materials in the future?
Well, think about it. Right now, we usually start with a problem, and then we try to find materials that fit.
Oh, okay.
It's like forcing a square peg into a round hole sometimes.
Right.
But imagine if we could just flip that whole approach on its head.
So instead of like looking for a solution to a specific problem, we start with all these new materials and figure out what problems they can solve.
Yeah. It's like suddenly we have this massive toolbox filled with amazing new tools, and we can build anything we want.
And discover things we never even imagined.
Exactly. It's not about finding a needle in a haystack anymore. It's like we have access to the entire haystack.
That's an exciting thought, but, it's also a little intimidating. It raises another big question. How do we even prepare for a future where material discovery happens so fast?
It's going to be a challenge for education, for research, even for our values as a society.
We have to adapt to a world where knowledge is constantly changing and innovation is happening at warp speed.
We need to embrace lifelong learning, collaborate across different fields, and stay curious. We need to be open to new ideas, to new ways of thinking.
This deep dive has been eye-opening. We've gone from the microscopic world of atoms and crystals to thinking about the future of science and the role of AI.
We've explored some groundbreaking research, and I think we both agree it's an incredible time to be alive.
It really is. And to our listeners, we leave you with this. If AI can unlock the secrets of materials, what other mysteries of the universe might it help us solve? What other incredible discoveries are waiting for us? Keep those questions in mind, stay curious, and until next time, keep exploring.